And for those of you still joining, this is part of our weekly series where we've been highlighting some of the faculty from NYU CCS. It's great. I see a lot of student names that we recognize and also a lot of prospective students. I know Justin and others are always interested in PhD students who might enjoy their experience in Brooklyn with all of us. So hopefully if you're in that category, you'll enjoy hearing about Justin's background and his and the research that he does with his group. I think you're going to love it. So we're just about at 2:30. Justin, if you're okay, we'll go ahead and get started. Looks like you picked a good backdrop there. Looks like you're all set with some light coming in the back. But thanks for spending some time with us this afternoon.
So yes, happy to do so. Thank you for having me.
You bet, you bet. Well, what we'd like to do is really start maybe having you share a little bit about your personal journey, like to both computer science and also cybersecurity and software, and take us up to the point where we are now. But how did you get to it? Like, were you like a kid who liked programming and decided this was your life, or what was kind of your journey coming to this?
Yeah, so from a very early age, I loved programming. My parents bought an old Commodore 64 when I was, I think, 7, and I taught myself how to program Commodore Basic on that. And then they got an 8088, and I had that for a while. For those of you who don't know, around that time, that was when I think we got a new graphics card and a new monitor that could display 3 colors. If well, 4 technically if you count black. You could do black, white, magenta, and cyan. And I actually, a lot of games that I had around that time were very, very simple games. Sometimes you'd go in a magazine and you'd type in like a page of text and that would be a game. And so I taught myself how to do things. And even at that time, my skills kind of developed and computers got more and more complicated in the early and late 90s, I went and started to do things like write my own games, my own programs. And I love to break things. I always love to break into things and do things like that. So one of the most fun things for any game I enjoyed was to hack the save games and or remove the copyright protection. Of course, with my licensed copy, only for my own purposes, never distributing. But those were the kinds of things that got me interested and excited about this.
Were there any, when you're going to school, like in high school and so on, were there some teachers that that pushed you along there a little bit, or when did you get the bug to maybe get involved in computer science?
So yeah, I had one really formative experience when, so I actually, when I finished high school, I didn't have a great GPA. I hated school. In part, and when I never interacted with an adult or really anybody who knew more about programming than I did when I was, until after I left high school. And I thought computer science was just programming. And it's like, well, I know BASIC and C and Pascal and a couple other languages. Therefore, I know everything there is to know in computer science, which was kind of my very naive 17-year-old self. And I actually joined the military, enlisted out of high school because I had been doing network and system administration part-time just as a job, something to do when I was a high school student. And I wanted to program. And I didn't think I could get a job as a programmer without professional experience and without a college degree, which I think it was definitely wrong because this was starting to be the late 90s. So I probably could have, but I didn't realize that. And so I went into the military. I never did any programming the whole time I was in. I was never asked to do it. I was told I was going to do it all the time. I never did any of it. I did system and network administration and a little bit of security work professionally, things I'd already kind of been doing. But I took my first my first classes at the University of Arizona when I was there, when I was stationed at a base in Arizona. And when I went to, they only taught upper division classes. They expected you to have the lower division classes from a community college because this was a branch campus. And I went to talk to the professor who taught the classes, most of the classes, and also advised them. And he, I said, look, I really want to take this operating systems class. It looks really interesting. He's like, well, if you look at the prerequisite chain, this is the last that most of our students take. But I was, this kind of young, arrogant, 20-year-old guy. And finally, I kind of talked my way into it. And he said, I'm sure we're going to drop in the first week or two. But I took the class, I got an A, and it was the hardest class by far ever, because I essentially had to learn. So I was missing from all the prerequisites to do well in the class. And then I was just loving computer science. I learned so much every week in that class. I learned so much about why things are, and so much about how to do computer science and what it means. And I just found it so fascinating. I asked a question at one point in the class, I remember what it was, but the professor said, I don't know that anybody's asked that question before. I think that's an open research challenge that no one's maybe thought of. It was something, I think, dealing with cache page addiction or something like that. And that just got me the thirst. Like, I really understood, started to understand the boundaries of computer science and where I might be able to jump in and help out. And it got me very passionate about that, and very passionate about also being an educator later in life.
So cool that the interest sort of found a place to feed your, something that had been there. You and I both meet a lot of people who, go into something in sort of this planned sort of way, like I'm going to do computer science because I'll get a job and so on. For most of them, myself included, it's just this thing that is inside you, and then you find a channel and you realize you almost found home. When you get to a computer science department, it feels very comfortable. They think the same way as you. It's very cool. So, what did you tell us about your PhD work? What did you do the work in?
So at that time, there was this new research network that had just sort of been formed called Planet Lab. And it had this radical concept that what they're going to do is they're going to put a whole bunch of computers, like any university that wants to join sets up 2 computers, and you have a way to get accounts on those other computers to go and run like sorts of experiments that you would want to run. So eventually it came up, and there were hundreds, 600-700 sites, and over 1,000 computers you could get access to. And no capability like this existed at the time. This was 18 years ago or so, like 2002 up to 2005. So the cloud wasn't really a thing then. And this just ability to go and get access to these resources was amazing. At that time, I was also looking at this, and I realized that what they really needed is they needed also a good package manager. They needed a good way to install software here, because you would go in and you would install things on 1,000 computers, and that was terrible for lots of reasons. One is you'd kill wherever you were downloading your updates from. And the second was that at the time, most people were writing, or there was a lot of people writing experiments in Java. And so I forget, but they did some measurement, and they found that something like half of the disk space was just the same copies of Java on the systems or something like that. And everybody kept downloading, either the same version or, 2 different versions of Java for everything they were doing. And so I set out to write this package manager that was designed to work in this space and to be efficient, and to make it so you didn't have to download the same thing multiple times, to make it so that you could do that in a secure way, and to also make it efficient when you had many parties downloading the same content. And what's interesting is this thing that I built, which I was building on this research network that was a new thing. Nobody knew if it was going to be important, but I effectively built the first package manager that was specifically designed to be used in the cloud. And a lot of that work that I did, when I went later and to try to figure out, well, we had all these security challenges, we had all these issues we had to address. How did other package managers address these issues that were common issues? Things like dealing with mirrors that might be malicious or other things. We found there were huge security problems that basically every Linux package manager that we looked at, we could root their clients that came there for updates without compromising a key or anything, just being listed as a mirror. And so that really got me to be very interested in, of course, fixing that problem in practice. And at first I did what most academics do, is I wrote a paper. And when you write a paper, that is often the end of the journey for academics, which I think is a big mistake. Because when I wrote the paper, there was some chatter about it, but nothing happened. And then I went, and at the time there was a big news site called Slashdot, which I think is still around, but was like a major, it was the news site of the day. It was the Reddit, the, whatever of the time. And it got covered on Slashdot, and all of a sudden everybody cared and everybody worked on the problem. And then we got fixes into App, Yum, Yast, Pacman, like all the major package managers adopted this security model from my work into their package managers, and we were able to get kind of everybody to, with a few stragglers, as you always have in the space like that, to move along. And so that really got my passion about not just doing something and writing about it to my academic colleagues, but also making sure that that work goes all the way into the software that runs on my computer and yours.
Interesting. So to help us with the journey from Arizona to Brooklyn, how did that happen?
Yes, so I was finishing up as I was finishing up my PhD, I wasn't sure what I was going to do. And a professor at the University of Washington had seen some of my work and approached me at a conference. His name is Tom Anderson. And he's a very, very known, very highly respected and a person in the field in operating systems. And so he asked me if I wanted to come do a postdoc at the University of Washington. And so I did that. And that was a really nice experience. I developed a platform there called the Seattle Testbed, which was basically like a peer-to-peer cloud environment, like a fog computing. You sometimes hear that term, or edge computing thrown around, where we had tens of thousands of laptops, smartphones, PCs, everything like that, running our software around the world. And you could go run these distributed measurements or other things like this in order to go and deploy your code. One thing that also really helped me, which is kind of ironic, but he went on sabbatical while I was there. So he was gone. And that was in some ways great because I got the chance to work with a lot less supervision and did things like I wrote grants while I was there, which I believe I'm the only postdoc ever at the University of Washington. I may always be the only postdoc to get a single PI grant while there, because it turns out it was against their institutional policies, but they hadn't really been paying attention. And so it was interesting to do, and it helped me in many ways, and I think also helped me to be more prepared to be a professor when I was ready to leave. And when I was ready to leave and go on and get a faculty position, I was very interested in going to a place that was very culturally diverse. I wanted to go to a place that was very, where I felt like I could learn something by living there, not just by being part of the faculty. And so I applied to 70 schools, a lot of them international, but before I heard back from anything or really knew anything about the schools, the number 2 school on my list of 70 was NYU Tandon. And I was very happy to end up there. When I found out things about my number 1 school, which was University of Singapore, I actually realized that I really preferred NYU anyway, and was really happy that they were very excited to have me come as well.
Well, that's great. We couldn't be more pleased that you're part of our community. Now, so there was an awful lot of people listening here. I know a lot of prospective students. Tell us a little bit about the research and about your group and what you guys have been doing the last couple of few years.
Right. So everything, we've had this mantra of making an impact in practice. And so some of the things that we've done is we built a compromised resilient way to distribute and deal with software that's widely used across a bunch of different industries. It's adopted by the Linux Foundation. It's a Cloud Native Computing Foundation product. And it's one of only, I believe, about 8 or so projects in there to reach the highest level of maturity, which means it's like the most widely adopted and most considered like at the highest level of support. And the others are things like Kubernetes and Containerd and Prometheus and other names that you probably recognize. So we've been very pleased and very much enjoying that process. We've also worked in a bunch of other things like Git signing. Git uses our tag signing model in production as of September of 2016. So if you're doing Git signing and stuff like that, you're actually using our code and our security design for that. We've done like automobiles. Quite a large number of automakers are using a security framework that we built called Optane. It's been standardized by IEEE ISTO and is also been rolled out to protect vehicles. But I've worked on a wide variety of other types of things. One project that's very different that I want to stress because it's very different is maybe 4 or 5 years ago, I noticed, so there's all these things they tell you like in your code when you write C code, like don't use this structure, or don't indent this way, or indent this but not that, or
Yeah.
use this pattern. And
Style guidelines.
yeah, and it turns out that the way that people came up with those is they basically just asked people like, what do you think is good? And people just like made up their own list. And it turns out that there really hasn't been a quantitative way to actually derive and measure those. So I had a PhD student of mine, Dan Gopstein. We went and we explored this problem and came up with a way to derive them in a great way. We had a way to show that these existed in a huge array of different projects, and that lines that had these patterns were much more likely to be result in bugs, were much more likely to have comments next to them explaining.
Cool.
And so it really has like a big impact. We won multiple best paper awards for the different pieces of work here. Yeah, I'm very proud of that work.
Back in the day when I was at Bell Labs, there was a guy, it was many years ago, named Bill Plowsher. He used to write books under PJ, who wrote the Elements of Programming Style. And it was what you said. It was a bunch of sort of suggestions that made sense, almost like the Strunk and White, like you ought to do this, ought to do that. And then we had those old tools like Lint that would try to go in and, find the problem. But if you can derive something and connect it to code quality, that's awesome. I would think that would be interesting. Hey, I want to back you up to the automotive work. What were you trying to protect? What are you guys focused on protecting automobiles from? That's a very rich and very an area of interest to a lot of students.
Yeah, there's a lot of concern in that field that nation state actors may go and want to break into vehicles. Just to give a tiny bit of context, an automobile is basically a whole bunch of small computers, some of them extremely weak, that communicate, have weak communication internally over usually very insecure local network. And then also there's only one or a few ways that they actually ever communicate out. So imagine you have an extremely constrained device that the only way it can talk out is through another device that is very likely to be compromised if someone breaks in to a vehicle. So you can see that this has a huge a lot of security problems. And so what we've done is we have a way to enable people to go and provide security fixes and other updates to those devices. They're called ECUs. inside of a vehicle to all the little computers in there, so that even if a nation state actor is trying to do things like go in and break in and steal signing keys from repositories and things, that the damage they can cause is extraordinarily limited. So one kind of theme that happens again and again from security systems that my group works on is we want things to be secure even in situations where some likely things may go wrong, okay? Because what happens many times is a company will go and they'll say, we're gonna have this server that we're gonna put an HSM in and it's gonna be secure, right? In fact, it was, many years ago, Red Hat, I think they were Fedora, like it was, I don't remember when the split happened, but at the time they had a break-in and someone had broken into their build system and stolen the signing key that they used to sign all their packages. And then they went and started to sign all sorts of malicious packages. And so I saw the folks at a conference. This was around the time I was doing the Stork work and Yum was adopting my changes and stuff. And I was like, look, I want to work with you to help you fix this. And they said, well, don't worry, we have it under control. And I said, great, so tell me what it is. Like we should talk, everybody should know so everybody can get fixed. And they said, well, we don't want to tell you because we're worried that might compromise our security if everybody knows what we're doing. And for anybody who works in security, that's a huge red flag whenever you hear that. It's like
obscurity, right?
Yeah. And so, but I did find out because like about, I don't know, 6 to 8 months later, they had a break-in, and after their break-in and their disclosure, they announced what they were doing. They'd basically gone and used something like an HSM on their server to make sure the key could not be taken off the server. So instead, what happened is when the attacker broke in again to their build server, they just uploaded the malicious packages that they wanted to sign to the server and signed them on the server. So it really provided them effectively no added security. And so what we do is we design systems where, for instance, in TUF, this CNCF, Cloud Native Computing Foundation, Linux Foundation project that's used widely across the cloud by Amazon, Google, Microsoft, IBM, Docker, you name it in the cloud. It's the case that the keys that you keep on the server, even if the attacker compromises them, they don't have the necessary keys to do things like sign this to say this is a valid update. They can only sign things that say things like, there hasn't been an update today. So they can lie to you and tell you when there hasn't been an update, even though maybe there has been one, but they can't say this is a valid update. And there's a big difference between what an attacker can do with those different, levels of different abilities to attack.
It's interesting. The model of having a somewhat heavier, reliable connection, like over the air or something, and then having, like in your case, CAN bus with these ECUs on a car, that model probably applies to a lot of other things, like an OT environment through a gateway. And so do you tend to work kind of at the model and framework level and then apply it to practical problems, or do you guys kind of dive into a domain first? What's been the philosophy?
Well, so when we worked with the automotive space, we were fortunate enough to work with some very, very smart people at University of Michigan has a Transportation Research Institute.
Oh, okay.
And a lot of the automakers, in fact, even our very first
So
meeting.
they had an application in mind immediately that they wanted you to look at.
Right. And so we came in kind of, very naive about what it was to be an automobile and to run in an automobile. And I think they were very naive about what it meant to secure the problem. At least some of the people were. And so by getting, working closely together, we got to a good space. So one of the things that I'm really hoping to do is I'm hoping that we can do a very similar effort for other spaces like the medical device. Nobody wants their devices at the hospital, which are actually surprisingly easy to hack in many cases. I went to a hackathon where I, and I'm not like an offensive security expert. I'm not like a, I'm not the guy who's like, I can break into anything. I build defensive systems, but within 10 minutes of being invited to this hackathon, I was able to get root access on a medical device. And within an hour or so, I was displaying a message saying, if you don't, transfer money in Bitcoin to this address, then we're going to kill this person.
Yeah.
So, it's, I think medical devices haven't been hacked as much in the news because they're expensive to get your hands on. But certainly nation state actors or other people like that want to go and hack these devices, many of them are 20, 30 years old. I mean, think about how hard how hard would it be to hack? Like, your biggest problem is, isn't finding security flaws. It's like making code, that exploit code that's going to run on that 20 to 30-year-old system in many cases.
I've got a question here from one of the participants, Roger. He's sort of half apologizing, but it's a perfectly good question. He's asking about programming languages and saying, hey, what programming languages do you recommend that people spend their time on?
Absolutely think Python is a great language. In fact, the reference implementations, like I would say that probably 75 to 80% of the code in my lab that we write today is still Python. And it's perfectly acceptable for most cases, and it's very readable. Other languages, it's good to know. It's good to know C because there's so much written in it and it's so important. And I would say you can make an argument for other languages too, but that is going to depend a lot more on your domain.
Yeah.
Certainly some awareness of the kinds of things Rust does is really helpful. And Java is kind of interesting, both because it's used in the mobile space for Android currently, but also because there's a lot of things that were done in the design of Java that turned out to be really bad ideas. So it's kind of one of these like historical relics that it's nice to look at and know about, so that when you think about a system, you can think about things like, is it really a good idea to have basically all of our standard library code be privileged? Well, no, it probably isn't, because then you end up in situations where you can have a bug in your time zone library and somebody can use that to execute arbitrary code with the privileges of the Java virtual machine, which is a weird thing, that a bug in Java, in code written in Java, would let you like escape the all virtual machine protections and do arbitrary memory access no matter where that bug is.
Right. Justin, one of the questions that we get asked in advance, this is kind of a good way to start planning our close here, is coming to Brooklyn. What was your experience? And B, as your students come over, as your PhD students come, what's been their experience coming? Because a lot of people, listening are in non-US located, or in places where Brooklyn just seems about as different as maybe moving to Mars. What's been your experience coming to NYU and being part of the community in New York City?
Yeah, Brooklyn is great. It's extremely multicultural. It's extremely safe. It's just like this nice area where I walk down the street and, you'll hear people speaking, 8 different languages as you walk 5 blocks down the street. And you can also, there's just so many different types of food, and well, when the city's open, at least. But it's New York. New Yorkers, they have this reputation for being very like saying, "Oh, New York has the best of everything," and for overstating that. And I don't think New York has the best of everything, but it has really good everything. So you don't have to worry about being homesick if you come here from another country. You're going to be able to get some of that food from wherever it is that you're from, and it's fantastic.
I sure agree with that. And maybe last question, Ankit and a few others are asking about, where does the decision to do PhD kind of come from? What is that, something in your gut, or is it a more logical decision, or what advice do you have for people who are considering it?
Okay. So it's important to understand what your longer term goals are, and to use that to think about whether you want to do a PhD. For me, I very much like being my own boss, and I like trying to, I like being able to work on any problem I want to work on. And I like targeting problems that might be hard to commercialize, but will have great real world impact.
Mm.
So if I can build something that saves a bunch of people's lives in automobiles and give it away and have, you know, 30, 40, 50% of the automobiles on the road use it in a few years, I would rather do that than make $10 million and have 5% of the automobiles on the road have it, because there's going to be an attack and a lot of people are going to die. And I could be sitting in my Central Park West penthouse apartment reading the New York Times about how many people died, or I can be here and have that number be a lot less. And I think that it's better for society and better for everybody. You know, I make enough money to live on, right? I'm very happy, very comfortable, so I don't need to be a multimillionaire. I think some wrong reasons I see people do PhD is, I think if you just want to go into industry and you want to be better prepared to be more attractive to industry, then doing a PhD is the wrong thing to do.
Yeah, I agree.
In almost all cases.
Yeah, it's true.
Yeah.
Waste of time and money. It's a research degree, not necessary for industry.
Right. And I've had people ask me, like I was on a panel with a bunch of other academics, and someone from a major car company stood up and said, we've been hiring PhDs out of top programs with great papers, and they're not very effective. What are we doing wrong? And I was like, you need to hire master's students. PhD students are over specialized in an area that doesn't matter in many cases. But yeah, to be a professor, it's a requirement, and to work in research labs, to have that kind of flexibility and freedom, there's a lot of advantages to doing it. So I have a student who's starting in Purdue in the fall as who is a tenure track faculty there, who I just graduated.
Wow.
And I have other students that have gone on and done extremely well in industry. So yeah.
Send somebody over to work with SPAF at Purdue, right? That's it. That's pretty good. But Justin, listen, I want, on behalf of all of us listening, a big group here, I want to thank you for sharing. It was really enjoyable. And for those of you listening, I hope it was a useful half hour for you. And we hope that we eventually can see all of you as part of our community at NYU. So listen, thanks everybody. Justin, I'll see you pretty soon. I guess sooner or later, we'll all be back in the classroom. That's going to feel really good.
Looking forward to it, Ed, and looking forward to seeing a lot of you in the classroom. Take care.
See everyone. Take care, everyone. We'll see you all next time.